Hey, so we're gonna wait a little bit to let other people join, and then we'll get started. This is the first time I'm doing this, so I'm learning as I'm doing it. All right, I'm just gonna get started, and other people can join or check out the recording afterwards. So many of us are familiar with Uniswap or alternatives. What it allows us to do is on specific networks, in this case on the Ethereum network, it allows us to swap one token to another. And so we would usually go about doing that on their website or on a using a web UI. But it's also possible to utilize the same infrastructure that Uniswap uses, the same smart contracts and the open source SDKs that they've released to implement the exact same functionality that allows us to swap tokens and have a script do that for us programmatically. And that's what I want to cover here. I'm not doing a video because I've been meaning to try the live stream format for a while now, and I thought that why not with this. So I've already made some preparations. Let me go over those so that you can then follow um, the implementation afterwards. I've set up a new account where I sent 0.1 ETH from a faucet, from a Rinkeby faucet. Let me actually do that once again. There was the chain link faucet that wasn't as annoying as the others. Connect the wallet. Traffic lights. All right. And so now we should have a 0.1 more ETH. Now, ETH is great, but we're going to be swapping between ERC20 tokens. So in this case, instead of Ether, we'll be using wrapped ETH. And then because nothing else, I couldn't find anything else that would work kind of okay on Rinkeby. Since we're using Rinkeby, we're using a testnet, we're not using actual ETH, and we're not swapping actual tokens. I'm going to be using the Uniswap token, but in real life, I imagine you could as well use USDC or USDT or any other ERC20 token that you can find the contract for. Excuse me. So our pair would be wrapped ETH and Uniswap. To do that, we do need to let's expand this. So we already have 0.05 wrapped ETH, but I wanna get a little bit more because I imagine we're going to be swapping a lot to test the implementation as we go. So one way you could turn your Ether into wrapped ETH is by going to the wrapped ETH contract. This is a Rinkeby contract, so if you're on the mainnet, make sure you're connecting to the right contract. And then you connect your wallet, the one that you have your Ether in, and then you just call the deposit function. So let's do 0.05 more. And so basically you deposit your ETH into the contract, and in return you get assigned a balance of wrapped ETH. And that's pretty much how wrapping your Ether works in a nutshell. So as soon as this transaction confirms, we'll have more. We should have 0.1 wrapped ETH, and that should be enough for us to demonstrate. Now, after we've done that, let me go over the implementation here. So as far as the dependencies go, we will be using Typescript. So I have some that are specific to that. And then the ones that are specific to the actual implementation are these three from Uniswap, the SDK, and then something called Smart Order Router. We're using .env for environment variables, and then we're also using a bunch of stuff from ethers.js because we need to, and because it's awesome. So our environment variables are as follows. We do need an Infura ID to connect to the blockchain. You can grab one for free if you sign up on infura.io. This is the private key to this wallet that I just created. There's no real ETH in it, so that's why I feel comfortable sharing this online. You would not want to share your real wallet's private key online. This would basically mean you losing all your money that are in that wallet. The chain ID is something that might look cryptic, but it's not. Basically, 4 here corresponds with Rinkeby. I know that 3 is Robston and some others, but I mainly use Rinkeby, and so that's what 4 is for. If you were to run this on the Ethereum mainnet, this would be 1 for the mainnet. So this is the Uniswap router address. It's a smart contract from Uniswap. The address, I believe, is the same both on the testnet and the mainnet. So this will be the same no matter where you run it. And then we have some configuration options we'll go into in more detail afterwards. So once we have our env file, we want to provide that, we want to have a way to expose it into our application. And so this is what the config.typescript file is for. After loading the environment variables so that they're available under this namespace, we go ahead and provide some defaults. Like if we don't have the chain ID, we want to default to the mainnet, etc. And then we just export them as constants. And then on top of that, we also built a few ethers instances, one for our inferior provider, and then another one is a signer, which is a representation of our wallet that we can use to submit transactions from, and then basically use that to initiate the swap itself. So these are the configuration variables. And so let's dive into our actual implementation. So here it is. It's not too long. It's about 100 lines of code. And we start off by importing our token pairs. So we're swapping wrapped ETH and Uniswap. And this is a custom thing as well, but it is based on Uniswap's SDK. We'll go into this in a little bit. And then on top of it, we also import our configuration required to run the swap. So then let's go into the token stuff, because that's what we do next. We have a token that we will be trading from. In this case, we want to trade wrapped ETH. And then we also have a token 2, which is the token that we will get in return. In this case, it's going to be Uniswap's UNI token. And so these we get from our tokens .ts, and that's what this file is for. So ignoring everything in the beginning, what we get basically is these two objects. And we get them by using this helper method, which builds ERC20 token, which is basically this token instance from Uniswap SDK with a little bit on top of custom functionality that I added to allow for a better, domain-specific language, and it just makes the code cleaner in our implementation. So we grab the token and we build on top of it something that's called TokenWithContract. And it's exactly as it's called. So we have our token, we have a function that takes a provider object and then gives us a contract of that token. And remember that any ERC20 token, whether it's wrapped ETH or Uniswap, it is a smart contract, nothing more. So we not only want to use the token instance here, we also want the contract representation, so we can call different functions on the contract like we have here. We want to know the balance. We want to know what is the allowance for a given for the given pair of addresses and all that kind of stuff. So that's why we've added this one here, and then we also have this helper function that takes a wallet, the signer, and then it checks if a required. So let's say we want to check whether this wallet has. Let's say we want to say, okay, we're dealing with wrapped ETH, so we'll then call wallet pass in a wallet, and then say whether that wallet has whether it has 10 wrapped ETH in it, and this will then resolve. It will return a promise that will resolve into a Boolean. So it's a pretty straightforward method, but again, just kind of a better readability, I put it into this object. And so that's what we get here. It's mostly the token object from Uniswap's SDK, and then a little bit of some sugar code on top. And the most important part here are these values. So you want to make sure that you pass in the correct contract address, and then goes the name, the symbol, and the decimal number for that contract. You can get that from, again, because this is a part of the ERC20 standard, you can get that from reading the smart contract values. So we then export these two, and then let's go back to our implementation. So here we assign these variables, and then we run our main function over here. And so what does it do? First off, the way that we want to run this is we want to say index.js, and then we want to pass in the amount of wrapped ETH that we want to swap into Uni. So that's what the first argument will be. Let's say I want to swap 0.01. And so here we check whether that argument is at all provided. And if not, we want to show an error and stop doing anything else because we don't know what's the amount it's going to be. And then after that check is passed, we then derive the wallet address from our signer. This is a helper function from Ethers, which when provided the private key, it will derive the wallet address from the private key. So this is where we basically, once we initialize the signer, we can just say signer get address, and then it will resolve to a string. So that would be exactly the same address that we have here. This one here will be our address derived from that private key. So we then do some formatting for our amount because we want to make sure that it has the right number of decimals. And then we grab the balance of our wallet for the token that we're swapping from. And that sounds like a mouthful, but it basically what I already mentioned is we want to make sure that the wallet has enough wrapped ether in it so we can continue with the swap. And if it doesn't, we want to show a helpful message and stop the execution again. So if that works, if all those boxes are checked, we then go ahead with the actual swap, where we use something called an alpha router from Uniswap. You can read more about how it works in their documentation, but basically it calculates the most efficient way of swapping one token into another. And then we could use that router object to create a route which will take in the specific details of our swap, of our trade here. So what it needs is the exact amount of the token that we're swapping from. So we just pass in an instance of a currency amount. Again, this is something that we use from the SDK that Uniswap provides. And then the second argument is, what is the token that we want to swap this into? In this case, token 2 is Uni. And then we want to make sure that it's the exact input. So basically there are two options here. We can say exact input or exact output, meaning we want to drive the swap based on the exact number of wrapped ETH that we want to put into it, or we want to drive it by the exact number of Uni that we want to get out of it. So in this case, I'm just going to say I want to spend 0.01 wrapped ETH, and I just want to get that exchange into Uni, but I don't really care how much exactly Uni, as long as it conforms, as long as it fits the current exchange rate and the slippage tolerance. So then the last one here is the wallet address. of the owner. So it's this address of our signer. And then some configuration specific to the swap itself, which is the slippage tolerance, which basically this is to ensure that even if the current rate changes, we want to make sure that the swap still occurs within a given buffer, whether down or up. So if we want to make sure that this swap takes place, even if the rate changes 5%, whether increases or decreases. And then we also give a deadline within which, so this is also calculated in our configuration, but what you need to worry about is basically this environment variable. So we want to make sure that the swap occurs within the next 30 minutes, or we don't want it at all. So this would be set here. You can set it to 5 minutes. You can set it to whatever number of, whatever amount of time that you feel comfortable with. Once that's done, once we have our route, we then show a helpful message saying this is the amount of token that we're swapping for this amount of uni. And then we do another check, which is very important here. We make sure that our router is approved to spend wrapped ETH from our wallet. And usually you do this once per token. So if this has already occurred, we don't want to repeat this transaction. So that's why we first grab the allowance of our wrapped ETH contract for this pair. And this would be the same as calling this method over here. So this one would be our wallet address, and this would be the Uniswap's router smart contract address. So if we do it now, let's see if I've already approved or not. So let's grab the router address. And you can see that currently our allowance is 0, which means that this contract is not allowed to do anything with our wrapped ETH in this wallet. So if that's the case, we want to approve. So we want to give approval to our contract, to the Uniswap's router contract, and let wrapped ETH contract know that, hey, we want to, whatever amount of wrapped ETH it is, this contract can handle it. They're free to, we do still need an amount, but usually you just pass in an obnoxiously large amount so that you only have to make that approval transaction once. So back to our implementation, once we have that allowance, if that allowance is not sufficient for the amount that we want to swap, so if it's lower than our wrapped ETH amount that we want to swap into Uni, we're going to say we're going to request the approval, and then we will construct a transaction for that approval. We'll grab the token from our wrapped ETH contract, and then we'll call that. We'll have 1,000 times more our amount to be approved. And again, this is solely to not have to duplicate this transaction in the future. And then we want to wait for that approval transaction to confirm and then attempt the swap. So if everything, if we already had it pre-approved, then this here would completely be irrelevant. We'll just skip directly to this part. And notice that we're calling the same attempt swap transaction functions here. The only difference here being that before we do it here, we want to also approve the router to use wrapped ETH in our wallet. So then the last bit here is these the actual swap, which is a pretty straightforward transaction, to be honest. Nothing really, nothing complicated, nothing out of the ordinary, except for after we have the route here, it's just a matter of populating the transaction keys in this object from a bunch of stuff that the route will calculate for us. So the most important part here is the you know, the meat of the swap is contained in this data value that we pass into the transaction. So that's what it is. And then we want to submit the transaction to our router contract address. This is going to be the value of the transaction. We want to do that from our wallet. And then we also want to set some gas limits with a 15% buffer on top, just in case, so we don't run out of gas. Now, we then build the swap transaction, which essentially just gives us this object with the populated values. And what this function call does then, we do another check. This has not been working that well for me on a testnet. I'm not sure why. So feel free to comment this out if this is acting weirdly for you as well. But the purpose of this is to make sure that we have enough ETH in our wallet to cover the gas fees. Because like I said before, we do need, even though we're swapping wrapped ETH to Uni, whatever gas fees that we need to pay has to be paid with ETH. So we need some Ether in our wallet, and that's what this check does. So if we don't have any ETH left, we don't want to continue with the transaction. We just want to throw an error and stop the execution. And then if that's all good, we'll then send a transaction on behalf of our signer of our wallet. And after the transaction confirms, we just want to output the transaction hash here. So that's basically all there is to it, to programmatically swap one ERC token to another using Uniswap. So let's try running our script. So I want to swap 0.01 ETH, and this should be similar to here. So 0.01 would give me, actually let's make it 0.1, would give me 0.15 uni. And we have an error. Module not found. Oh, because I was calling index.js, not TypeScript. So call that again. And so it's requesting the approval. And it will wait for that approval transaction to confirm. And I think it's going to wait until at least 3 confirmations. that is here. So the wait function takes the number of confirmations that you want to make it wait for until it continues with the execution. So let's check. I know that Rinkeby Etherscan is very slow to index stuff, so I do not expect to see anything here for now, but still, let's check that. Oh yeah, so this is our approval transaction submitted 48 seconds ago, and apparently we got an error of some sort. I'm sorry, let me... Okay, so that's fine, errors do happen. So our execution was reverted. Let's find out why. This is not too helpful as an error message. So let's see what we have here. Transaction failed. So let's check the So let's just run it again and see what if it's consistent. So this time it says that we don't need to submit for approval. So it will directly attempt the swap. It looks like there's still an error. All right. So we have 0.09 ETH. 0.1 wrapped ETH, and we were trying to... Yeah, maybe let's try swapping not the exact amount of wrapped ETH that we have. Maybe let's do a little less. Okay, in this case, I'm gonna need, let's check our transaction and see exactly what it is that we're sending. So at this point, I don't even want to send the actual transaction. I just want to check the transaction object. All right. So gas price. So this looks correct. This is our wallet value. Should be 0 because we're not sending any ETH. Gas price. I have a feeling there's something weird going on here. So what I'm gonna try to do is I feel like there's something not right with this estimation. So I'm gonna try to pass in just a large enough limit for the transaction to confirm. Let's say whatever. Oh, now we are running out of ETH to pay for the gas fees. I want to make sure that this is... So there was a swap. They were 167,000. Okay. We do not need the 18 decimals here for sure. So we can just do big number from, and then just pass in 200,000. How about that? Okay. So apparently the problem was with the gas limit, like I thought. This estimation here is, it used to work this morning, and then all of a sudden it just started giving me this weird value. So this is a way to bypass it. Not very elegant, but at least it makes it work. So if we go and check, first off, let's check if we at all got any uni after our swap in our wallet. We can do that by grabbing the Uniswap contract address, the Uniswap token contract address, and then adding it as a token in our MetaMask. And this is okay because this in fact is the same address for the uni token on the mainnet. Just make sure to pass in the symbol and the 18 decimals, and then import. And as you might have noticed already, we do have, so we have swapped some wrapped ether to uni, and we can also confirm it by going on the transaction page on Uniswap. This is a transaction that we just submitted. We swapped 0.05 wrapped ETH and got 0.076 Uniswap tokens. So we can do one more, let's say 0.02. And we don't really need to console log that transaction object anymore. So again, here's our new transaction. where we just swapped 0.02 wrapped ether to Uniswap token. So there you go. Here's how you can exchange one token to another using the Uniswap's underlying infrastructure. You've also learned how to submit approval transactions for ERC20 tokens. And even though this, in this context, this does not have much of a utility, but one way I think that as an exercise you could continue off of this is you could check out some of my previous videos where I show you how you can monitor a wallet for incoming transactions. And so you could, what you could build is sort of a bot or a monitor where it watches a wallet, and as soon as any ETH hits that wallet, as soon as there's any ETH incoming to the wallet, it will grab, let's say it will take 20% of that ETH, it will wrap it, and then it will exchange it to USDC token, and then maybe leave it on the same wallet or send it to another, up to you. But that will basically automatically take 20% of any incoming ether and then exchange it to USDC and put it aside. I think that should be relevant given the current conditions, and that could be a very nice exercise for you to explore everything that we covered during the last half an hour. I will keep the recording on YouTube. I'm curious how this format is going to perform compared to regular videos. If you do have any questions, or if you have any ideas or suggestions about next videos or live streams that you want me to do, feel free to leave them in the comments, and I'll see you in the next one. Cheers.